All right. Okay. So 2.2 is going to be our first type of differential equation. Now, this is going to be first order. And for the first couple of sections in chapter 2, right, I think 2.2 and 2.3, we're only dealing with first order differential equations. Okay. And so a first order can be written of the form, right? So dy dx is equal to a function of x and y. So this, I know some sort of a new notation, right? So, but this is a function of x and y in it, right? So basically, try to solve for your derivative dy dx, right, is equal to basically all your expressions are on the other side. Okay, so obviously that expressions can have x and y in it, right? And so an equation is separable. Oops, wrong spelling. So your differential equation is separable if it can be written okay in the form. Basically, you want to separate your x and your y. So basically your dy would be on the left, and then you have your dx on the right. So the dy dx is split. Okay. And then essentially your function has to be split as well. So you're going to have a function of y on the left and then a function of x on the right. So if you're able to do that, okay, then your differential equation is separable. Questions? Any questions on that? So if you're able to do that, right? So note it has to be a product, right? So it has to be dy times a function of y, then dx times a function of x. Okay. So here's an example. So number one, right? So the direction now is to solve. Okay. So you have dy dx is equal to k times y. So I want to see if this is separable. So first, I'm going to multiply dx to both sides. And so you get dy is equal to ky dx. And now I want to separate so that the y are on the left and the x are on the right. You can do that by dividing or multiplying only. So which means this is what we have. So 1 over y dy is equal to k dx. Questions? So this is separable, right? So you were able to separate the y's from your x's. And so you have now a separable differential equation. So now the next step, well, it's kind of like sort of the reverse of any derivative. Well, you now integrate. So integrate both sides, okay? So what's the integral of ln of 1 over y? So the integral of the left side is what? Right, so it's ln of absolute value of y, right? And then what's the integral of the right side? kx. Questions? All right, now it is an indefinite integral, so there are no limits of integration on here. So which means what? Plus c. Now both of them should have plus c on it, right? So there should be a plus c on the left and there should be a plus c on the right, but plus c is just a constant. And if you move the constant on the left to the one on the right, it's just going to become one big constant. So we really just need to put plus c on one side. It doesn't really matter which side. Now, typically we put it on the independent variable side. So that's the one for the x. So we're going to put the plus c on this side. Okay. Questions? Any questions on it? All right, now as much as possible, try to solve for y in explicit form. So what do I mean by that? I want the y to be by itself on one side, okay? And then you just have a function of x on the other. So you can do that for a lot of these differential equations, at least for a lot of your solutions. And so you try to solve for y in this case. Okay, so let's go ahead and do that, right? So first thing, I have to remove the natural log. And so to do that, I have to rewrite this in exponential form. So in exponential form, you have absolute value of y is equal to e to the exponent that's equal to the expression on the other side. So this would be kx plus c. Questions? All right, now we're gonna do this a lot. So I want you to pay attention on how this thing is going to be simplified. So we're gonna see this quite a bit. And so I don't wanna have to keep going through all of these every time out. And so we're gonna go ahead and explain right now one time how to simplify essentially this expression, okay? And so first, a kx plus c as an exponent means e to the kx, oops, times e to the c power. Well, e to the c is another constant. So which means I can rewrite this as absolute value of y, and I'll just put the constant in the front. So I'll call it c e to the kx. Now I can't call it c because I already called this one c, so I'm going to call this one c1. Questions? Any questions? Okay. Does anyone remember how to remove the absolute value out of an equation? So how do I remove the absolute value out of this equation? Does anyone remember? So what I mean by that is if this was my equation right here on the side, absolute value of x equals 3. How do I remove the absolute value? Does anyone remember? So how do I get x by itself on here? Write it twice. It's plus or minus, right? So you're going to get plus or minus 3. And that's how you remove the absolute value. So if I do the same thing here, this is plus or minus c1 e to the kx. Questions? And again, plus or minus C1 is just another constant again. And so that plus or minus gets absorbed and just call it a new constant. And so your final answer is y equals C2 e to the kx. And there is your answer. Any questions on that? Any questions? Okay, so I want you to try one. Okay, so example number 2. So dy dx is equal to e to the x minus y, which, by the way, e to the x minus y is e to the x times e to the minus y. Okay, so see if you can separate this and then solve by integrating both sides. Okay, so go ahead and try this out. All right, so again, this is separable, right? And so when you do, right, so first multiply dx to both sides, so you get dy is equal to e to the x times e to the minus y dx, and then divide by e to the minus y. And so when you do, you get e to the y dy is equal to e to the x dx. Okay. And then now integrate both sides. So when you integrate both sides, what do you get? So the left side would be what? E to the y. Okay. And then it's equal to, and the right side? E to the x plus c. Okay. Questions? All right, and then again, as much as possible, try to get the explicit form, right? So how do you get rid of the e? You take the natural log. So when you take the natural log of both sides, you get y is equal to ln of e to the x plus c. And notice there's nothing to simplify. And so this turns out to be your final answer. Any questions on this? Any questions? Okay. Now I do want to ask, okay, is the first equation linear or not linear? So is this one linear or not linear? This one is linear, right? So it is linear, so which means you can do this equation using the method we're going to go over in 2.3. How about this one? Linear or not linear? The e to the minus y tells you it's not linear, right? So this is nonlinear. So which means whatever we're going over in 2.3 is not going to work on this equation. Okay. All right, so now let's do another one. Okay. Now on this example, okay, you won't be able to solve for y explicitly once you've done integrating, and you'll see why we're going to actually leave our answer in implicit form. But let me give you the equation first. So this is example number 3, I believe. So number 3.